Thank you for the introduction, and thank you to be here following my session. And I'm here to try to share how we understand, or at least try to understand, the chaos in InfluxData and how we can try to do it together. So I tried to split these talks in two different main areas. One is a more traditional one that it's more about how you can use the InfluxDB and the other tools that we made to instrument and monitor a traditional infrastructure, because we are at the OSDC, so I need to do something with DC involved. So that's why I went for a more traditional part of the topic. And another one is about distributed monitoring and tracing, just because I discovered that it can be a really useful tool that developers can have to understand what's going on in a distributed system. So I think that if you are able to give to the developer these kind of tools, they can try to be less chaotic. So I'm a developer, I'm a friendly one, so I'm trying to fill the gap between developers and ops. That's the purpose of the topic, so be friendly with me at the end. If I can go, yeah. So, as I said, I'm a software engineer. I work at InfluxData, and I'm almost passionate about all the stacks. Maybe not the one that involved colors and UI, because I'm really bad, but the rest is kind of good. And currently, I'm working in Go. I'm an open source developer, and I like to share what I do. So that's why I'm a Docker captain and a CNCF ambassador, because it's kind of part of my learning process of my nature to share and trying to speak with people about what I'm doing. I work as a SRE in InfluxData, so I mainly take care about scalability in our cloud offering, because other than develop open source tool, we also have an enterprise license and a cloud product that we use to sell InfluxDB and all the stack as a service. I write blogs and I'm active on Twitter, so if you just send me something and I'm going to answer at some point. I love traveling, I grow my vegetables, and I cook. So here I was in New York counting MMs, a lot of them, trying to keep the situation quiet and monitor the situation. Here I was making gnocchi at home, they're really good. Here I was in Cuba in holiday a few weeks ago, a really good place. And here I was at the Azores trying to figure out how big a tree can be, and that was really big. Just to make a quick introduction and give you some context about what InfluxData does. InfluxData is a company, a startup based in San Francisco, and we have a couple of open source tools that can help you to manage time series data. What time series data are? Everything that has a time and everything where a time matters. If you are an IoT company, if you have sensors and you are trying to monitor temperature and you don't have data, and you don't have the time when the temperature happen, it's going to be a useless data. Same for logs. If you have logs and you don't have time, something weird. And even for metrics that come from services, CPU, memory, network, everything needs to have a timestamp. Without a timestamp, it doesn't have sense. And there are a couple of features that you need when you are working with time series, like retention policy or aggregation or math. And you need to have a efficient time series. So the first project InfluxData released was InfluxDB, a time series database that is open source and you can use it. After that, we discovered that the time series, the database wasn't enough. People were struggling with the same problems all over the time. So we had the Telegraph. Telegraph is our collector agent, so you can take it and install it in all your hosts, and it gets metrics out from everywhere. It has a lot of plugins, like more than 100 and whatever, so a lot of them, and you can write them and submit them to the open source project. They will be merged, and you can start to collect metrics from new services like Docker, or from container itself, or for more traditional sources like Proc, or a lot of other services like MySQL, Postgres. So you have your application, you collect all the data in Telegraph, you get all the data from your host, and you store the data in InfluxDB. Good. Now, Another project that we added to the stack was Chronograph, a UI to manage all the stack. So even capacitor, telegraph, InfluxDB can be managed from Chronograph. We saw a few talks ago that Grafana is also a really powerful dashboard that supports multi-sources, so you can use InfluxDB with Grafana there. Capacitor is our framework to process data and to make alerts, so you can stream data from InfluxDB and create alerts based on thresholds like CPU, memory usage, or you can combine them together, or you can have more complicated flow. For example, capacitors support a pool-based model as Prometheus, so you can configure it to grab information from your application or from your exporters, and it will store them in InfluxDB. So it's fully compatible with the Prometheus scraper. And that's it. I'm gonna work on them later, so this was just a kind of overview and context. What I mean when I think about distributed system, microservices is just one of the distributed system that you can work with. It's probably one of the famous one, but even queues are can be distributed, so you can have workers and queues. Usually the queue system usually are in H availability, so they are across regions, across data centers too. So it's a distribution. It's a distributed system too. Even a single application with multi-threads is distributed. It's not distributed across networks, but it is distributed across threads. So it's also distributed. And to more distributed system is big and spread across containers and data centers, and more is complicated. Another factor to understand how complicated it can be, it's containers, Docker, Kubernetes, whatever. All these tools accelerated how much we spread our processes around the globe, because with Kubernetes it looks everything like a big server, and you deploy containers that look like processes, and they go and come. So it's like a really chaotic environment. That's where chaos come from. So it's so chaotic that sometimes people just take these technologies without really think about why, and blame yourself if you did that, because now you are in the chaos. Another way to understand how complex a distributed system is to look at one request and understand how many applications it's trying to hit. And you will discover that it's hitting a lot more services that you figure it out. So even in a really big microservices environment, when there are 200 microservices involved, you really lost track about who is calling what. And it's also really hard to understand how to delete a service from the chain, because you don't know if it's seed code or not. So it's complicated. Logs are really useless in this kind of situation, because you don't have a stream anymore. You have a lot of them. You need to aggregate them, and you need to collect them together and try to understand which log come from which request, because that's the complicated part now. Also, event and metrics are hard to understand in a complex distributed system, because you don't know where they come from, and they need to be correlated together. And you need to almost rebuild a request from the beginning to the end and understand what's happening in the middle. So you can't do that anymore. You can stream and tail logs and look at it really fast and try to understand if it's too fast or too slow. I was doing that. It's hilarious. You can just follow a tail and see, this is so weird. It's so slow. Something's happening, and you try to detect the problem. This doesn't work anymore because you have too many streams and you don't know where to look. So I'm sorry. So tracing is all about aggregating logs and metrics using IDs. Usually, the ID is called trace ID, and it's the identification for a specific request. So let's say that you have an Nginx in front of your application, and whenever a request hits your Nginx, it has a trace ID, and this trace ID is propagated to the network until it comes back. And the idea is that you can query your analytics magic tool, and it will be able to give you a trace. This is a trace. I made it. This is a piece of art that I made. And as you can see, there is time over there and the list of application. There is an Nginx, an out service, an API, authentication again, and MySQL. So the idea is that all this information, every time that somebody calls one of your services, the request is floating to all these services, and you need to correlate them together to understand when it breaks or how long it takes, and who is the service that is blocking the request to go over. So one of the problems making this is that we write applications in a lot of languages, and so the instrumentation tools can be hard because it needs to be across languages, and it also needs to be across team, because at the end of the story, you need to have a single trace. So if every application and every team and every language is traced in a different way, you maybe won't be able to get a trace, and it will be useless. So distributed tracing and open tracing is one of the standards that you can follow. It's promoted by the CNCF, so the Cloud Native Foundation, the same foundation that helps Kubernetes, Prometheus, and Containerd, and other popular cloud projects to grow. They promoted this standard, and it's good for a couple of reasons. One of the reasons is that it's split your tracing tools from your application. So you embed the open tracing SDK that it's made in a lot of different languages, like Java, C, Go, JavaScript, and a lot of them, Python. You have the open tracing SDK, you inject the tracer, and you instrument your application with the open tracing API. So if you need to change the tracer, you just change the tracer on top, and your instrumentation code will be the same. That's good to avoid vendor lock-in and all this kind of stuff. So you have your application instrumented, and they are speaking with the open tracing API, and you can use a lot of open source or as a service traces to store your events. So Zipkin is one open source, Lightstep is as a service, Jaeger is open source and it's in Go, Zipkin is in Java, Updash and Instana. So there are a lot of them, even as a service one. So all these applications and all these companies are using tracing and open tracing. So Docker supported, Red Hat in OpenShift, and Giant has it. So there are a couple of use cases, and it's maybe 2 or 3 years old. I mean, 2 was last year, maybe 3 now, if I'm counting good. And there are already a lot of companies and implementation, because this is a common problem that when you design microservices and distributed system, you have and you need to figure out. Amazon has a service that is called X-Ray that does that as a service. And so that's why I think that in a data center, maybe this kind of service can be good to have and to provide to the user. As I said before, a lot of implementation are already available. So Express is a JS framework, gRPC has it, Java has an SDK, Go, Ruby, Python, Objective-C, and so on. So it's a solid standard and tools that you can use and promote. When you start a tracer, then when you start to trace your application, the problem is the high cardinality, because you are almost creating an ID for every request. And usually developers and people are using that trace to look up information from the storage. So that tag, that request ID, that trace ID is indexed. So the cardinality for a database can grow. So you need to take a good one. So this is mainly the problem around tracing, how to have an optimized storage for that. In InfluxDB, we are doing some tests, and luckily we saw that our developer and our support team doesn't look for traces for too long. We usually look for traces for the last week, because maybe somebody send us a ticket and say, this request ID failed, can you figure it out? Or we are testing and we need to understand what's going on. So it's a really, the life cycle is really short, so we can, in InfluxDB there is a feature called a retention policy that you can set your custom date, and after that time, all the data will be cleaned. So we have a retention policy in 1 week, and traces older than a week are automatically removed from the database. And what you can do is you can have a procedures that downsample data and store them in a long-term storage. So we set a week of retention policy, and after that we remove the old one, and we use capacitor to downsample traces and keep what we need from them in a separate long time storage. That usually is InfluxDB, it's just a different database. So this is an example in Go to, as you can see, there are two different packages. One is called Zipkin, and one is called Open Tracing. And I put this slide together to show you the idea about having the tracer that is different from the instrumentation code that you will have in your application. So the idea is that when you init your application, you create the tracer and you inject the tracer in Open Tracing. And after that, you don't need to care about the tracing anymore in your application. You have the Open Tracing one, and you use it forever, never. If you need to change the tracer for some reason, you just need to change the tracer in your main configuration and move over. That's how you create a span in your code. So you get the Open Tracing library, you get the tracer, and you start a new span. Every line inside a trace is a span. So a trace is made of spans. And when your function finish, or when you need to close the trace, you just, in Go, you can defer it. So it's the last stuff, the last function that is executed when a function ends, or you can just end it manually. So that's it about the Open Tracing part. And it's a standard that it's available, and you can read it on GitHub and in that site. So I put together a couple of slides about how do we create a tracing infrastructure in InfluxData using our tools. And that's the idea. You have all your application over there, and you need to instrument them. Currently, the problem is the instrumentation, because it's hard. You need to keep developers and give them the ability to instrument it. But with the SDK, it's not too complicated. And yeah, that's the breaking point usually. We have our collector is called Telegraph, and as I said before, it exposes a lot of plugins to collect metrics from different systems. One of them is called Zipkin plugin that exposes a compatible API with Zipkin. So what you can do is to instrument your application to use the Zipkin SDK and to store all the metrics to Telegraph. Telegraph will collect them, a bunch of them. Usually, by default, it's 10 seconds, and every 10 seconds, it sends metrics to InfluxDB. This is really good for age availability, because you can have a bunch of Telegraph. They don't have states, so if you're going to lose, if one of them is going away, you are just losing 10 seconds data in worst case, so it's not super critical. And yeah, you can send them to InfluxDB, or in our case, we are sending them to capacitor, and I'm going to explain you why later. So, Zipkin, Telegraph supports a lot of plugins, and there is a long configuration that you can create to say to him, expose this or look for this MySQL over there. So it's all well documented, and this is a screenshot from the GitHub Zipkin plugin. So you just need to put that stuff in your configuration, and it will magically expose HTTP port on 94.11 compatible with Zipkin. We put a capacitor in the middle between InfluxDB and Telegraph, because we was collecting so many traces that we wasn't able to store them, or our cardinality was growing so much that was critical. And we have a particular path that is the right one, that is the route that all our clients are calling to store metrics, and there are too many requests to be traced, all of them. So we decided to put a downsampler in the middle to get, currently we are getting the 20% of the traces, but it's a dynamic configuration that we can change. And what I was trying to say here is that you should have a smart downsampler at some point in your chain to dynamically configure what you are happy to store and what you aren't happy to store. Because if you have high frequency API requests, store all of them can be critical and maybe can also be not really important from a feature perspective. So have a downsampler can be good. And at the end, we store all the points in InfluxDB. So they are stored there and safe. We don't have a UI. So we decided to go without a UI currently, just to give to our developer the ability to trace and to query. Usually, my colleagues are really good writing query for InfluxDB, so they don't have a lot of problems. But I just decided to say that now, because if you're looking for a UI, there isn't yet. But the idea is that from our use cases, we will be able to at least have some prototype working at some point. So. And I built this example with InfluxDB because I'm comfortable with that tools and I'm using them. But you can directly use Zipkin or Jaeger or another tracer. They usually support multiple backends. So I know from my direct experience that Zipkin support Cassandra and Elasticsearch, probably also others, I don't know. And the same for Jaeger, they support Elasticsearch and Cassandra. So you can go with them. So part of the process, these tools, metrics, log, traces, are all about understanding application and system. And the process that I learned, and I try to keep my colleagues in the loop, is this one. So you instrument your application to observe the metrics that you are able to get. You observe a system to understand how many memories or CPU you are getting. When you observe them, you try to downsample and aggregate data. And when you aggregate them, you can take action, so make alerts or automation on it. The aggregation is really important for what I discovered, because if you look at a complex system from only one matrix, you are gonna have trouble, and usually troubles means that you get paged for nothing. Because if the CPU is growing, but for some reason your system is able to balance itself, why you need to be paged? So I think that the secret here is really that you instrument your service, you get everything you need everything you can from your servers and from your application. You watch how it behaves, you understand how your application are working together, and from that you are able to take action and alerts. If you don't do that, you're gonna wake up in the night. How do you keep developers in the loop? They should deploy their services, and with all the tools that we saw today, Prometheus or Terraform, Kubernetes, they are able to do that. I'm a developer and I deploy my code, and if they do that, they should be also take care about it and be on call for the part that represent their capability. That part is really hard because you don't know, like it's hard to split what and who calls where, but it's something that you figure out with the right metrics and with the right observability on the services and on the application. So keep developers in the loop, it's really important. And we are trying to present our services when we write them, and we write capacitor alerts inside the same repository, and we apply them. In this way, they will also be involved in something that is not just the code that they are writing, but it's also the operational point of view. Also because they are the developers, so they know what is critical or what should be critical, and they can expose the right metrics out from their application. And we can use that metrics, and we can correlate that metrics with the metrics that are coming from the servers, or from the containers where it's running. Yeah, keep everyone in the loop and responsible for what's happening in production, because that's where the funny stuff happens. Yeah, that's my need. I learned a lot of stuff running my code in production, so I think it can be valuable for everyone. And as we heard a lot, everything that we write expose an API, so developer can use them. Even from an infrastructure perspective, we should expose APIs that people can use. I saw I followed a talk from Kelsey Tower a few months ago, and he was developing, deploying a scalable capability inside the application itself using the Kubernetes API. Maybe that is it's too much, but it's definitely an idea. If we expose API, we are able to do magic stuff. For example, create runtime alerts with capacitor is the same the same example that we saw before with Terraform and PagerDuty. We are doing similar stuff without without Terraform or with capacitor and a bunch of API calls because it exposes API, so it's simple. So, as I introduced you before, server containers and VM are really dynamic, and they change how frequently we deploy code and how spread around data centers we are. And for this reason, we can't name them anymore. So they don't are pets or animals that we have in our house. They go and come. Yeah, that's sad, but it's true. And often it's really simple when you have a problem to just remove the server from the production pool, replace it, and figure out it later why it's not working. Because if you are in a really dynamic environment, you don't need to keep a server that is failing for too long. You just remove it from the pool, the autoscaler will add a new one, and you troubleshoot the problem in that servers later. So this is a practice that it can be followed, and it helps you to try your automation. Yeah. The server doesn't have name. Usually it has role, and in Kubernetes they are called label. So you attach label to your nodes, and you create your topology. For example, you can label servers that has SSD mounted inside, and you can mount servers that are running that requires SSD. For example, InfluxDB is a data intensive application because it's a database, so you need a SSD, and you can say Kubernetes deploy these containers only in servers that has SSD. So your servers doesn't have name; it has roles and features that you can use to identify where to deploy an application. DevOps is an attitude. It's not something that it's not a role. I think that we are all software engineers. Some of them are more close to servers and automation compared with others that maybe likes more something else, like e-commerce or whatever. But it's more like an attitude. So it's something that can grow and can be injected or teach to new developer, so you just require some time. So I'm back on a more traditional use case that doesn't involve traces. It's not the really oldest possible because it involves Kubernetes, but let's imagine that every node is a server and there is a Kubernetes, and it's part of a Kubernetes cluster. How do we monitor this? In InfluxData is using Telegraph. We deploy a daemon set. Daemon set is a Kubernetes resources that it's designed to deploy agents because you can say deploy this daemon set in every server in my cluster. So what's happening here? You're saying, okay, deploy one Telegraph in every server in my cluster, and Telegraph is configured usually to take all the metrics from your system, memory, CPU, network, disk, and whatever it can take, plus the Docker information, so we can manage the Docker socket and see what's going on. It also takes metrics from the kubelet itself, so we can grab information from all the Kubernetes processes that are running. So now you have one Telegraph for every servers, and you are already getting a lot of good information from your system because you know almost everything that is running inside and how it's behaving. Other than that, in a separate namespace, or you can have it, if your infrastructure is really good and you are looking for edge availability, you should have your monitoring namespace in another data center or replicated in another place because it can be in your same infrastructure, because if your infrastructure go down with your monitor, you don't know that it's down, you don't wake up, but it's not a really good experience for all the other people. So this is just an example. So you have your monitor infrastructure, your monitor namespace with InfluxDB and chronograph for your UI, and you have a telegraph in every node. So your developers start to deploy application. And how do you manage your application? There are different ways. So you can instrument capacitor, or if you have Prometheus, Prometheus can grab them from all the places. But usually what I learned is that every application has its own way to tell about itself and to expose metrics. So some of them are new application and they are exposing the Prometheus format with slash metrics, so they are super easy to grab, but other of them are more like creepy around that, and you can't do that. So, or even if you have a high intensive application and you need to load every point, and you can have a pre-aggregation, the Prometheus exporter can be your final choice. So you maybe need a UDP collector that can get high frequency metrics and store them in InfluxDB in TCP. So Telegraph give you the ability to do all these kind of tricks. And what we do in Kubernetes language is called sandbox. So in every pod, a pod is a you deploy your application inside a pod, and a pod can contain more containers, and not just the one that you are deploying. Every container inside the same pod are sharing the network namespace. So basically, you can call them using localhost, and they look like they are together. That's really a powerful feature, and we use it for Telegraph because we deploy a Telegraph inside every pod, close to our application, and based on the needs for that application, we are able to configure the collector in the best way. So for example, for etcd, that is the guy over there, etcd exposes a slash metrics Prometheus-like scraping entry point. So you can we just configured Telegraph with the Prometheus input to scrape the metrics from the entry point. But if you have an application like another application that doesn't expose that capability, you can but maybe expose a UDP socket, you can deploy a Telegraph plugin that listens to a socket and read the metrics from your application. So it's really, really flexible in this way. When you are in a distributed system, you don't really care about memory or this kind of stuff. From my perspective, we care about the state of the application and events, because as I said before, memory, CPU, they are going and coming. My containers is going away if it gets too much memory, because the scheduler is going to kick it away. So I don't really care. What I care is that my event. So if somebody is asking me if I received a create user event, I need to be sure that that event is stored and is safe. If my application crash, it should be able to get the event again. That's what we call a resilient application. So they can fail and come again. So what we are really monitoring for is the event in our application. It's not really nothing more than that. How many of them I'm able to solve, how many of them I'm losing in the middle of something, and so on. We also care about data, but data is a completely different topic, so I'm not going to spend a lot of time on that, because that data warehouse is something that I don't know about. So I just know that we care about data. So I'm just going, this slide is to remember you that we care about data too. So this is an example about how a really bad retry can behave in your system. So this is an example of trace took by Zipkin. And when you are designing resilient application, if you're doing that in a not really good way, you have a retry in every API request, and if it fails, you try again. Maybe for 10 times, maybe for 10 minutes, maybe, I don't know. It's on the developer to set this resilient methodology. But if you have a problem and all your requests are failing, your application is just retrying and retrying and retrying again. So this is a really long trace with 156 spans, so almost every span is a retry. It's trying to do the same stuff again because it fails, and it wasn't able to understand it. It was a failure for another reason. And the request took more than 10 minutes, and probably somebody killed it at some point. So when you listen about resilient application, try to investigate about what it means, because if it means a retry, it's not going to work. So let's summarize everything. Monitor distributed system is hard, so if you are migrating from a traditional infrastructure to a distributed one, also think about how to monitor it, how to recover, how to understand your applications and your system, because it's going to be different. Open tracing and distributed tracing is one of the tools that you can use to have a better visibility on your system. Keep people in the loop, because they are making the application and they know probably something more about why it doesn't work. And DevOps is an attitude, so let's grow it together with our colleagues. And servers, containers, and processes are pet, not are not. Probably this was my brain kind of trying to convert me. But they go and come, so don't look at them in a too serious way. Look for application stated events, and listen to your application and have fun. So when we are looking for a, when we analyze a system, the data are just one of the problem. That's what I tried to say during my talk. You can collect all the data of the world, but if you are not able to understand them or to collect them together or to keep them together or to design smart alerts because you don't know how your application behaves, all these data are going to be useless. So to answer your question, you need to have a good collection, metric collection, but also a good alerting, a good downsampling application, and aggregation tools. So that's it for me. Thank you.
Thank you, Gianluca. Are there any questions? So if you have no UI to see, Gianluca, if you have no UI to see what you get from your capacitor, is it right? Then how you can visualize them?
Currently, we are using that that infrastructure because we are trying a new set of tools, and we are developing a new system. So that's why we are also trying this tracing methodology, and we are tracing our infrastructure. So we are directly querying our database. Our InfluxDB supports a SQL compatible language, so we use almost SQL queries to get a single trace with all the span, and we correlate them. It's not. I hope this won't be the final solution for us, but that's what we have. And if you are looking for a complete kind of solution, as I say, there is Zipkin or Jaeger that has a nice UI, and you can store all your points in Zipkin. It will use Cassandra to keep them safe and query them via UI. So it will work.
You told some slides before that you write them with Telegraph into InfluxDB. Is it right?
Yeah, Telegraph is our collector, so you get all the metrics inside the collector and store them to Influx.
Is there a way to visualize them with Grafana, with the Influx DB as a backend?
Yeah, you can do that, but to create a trace, you need a proper graph. So I don't know if Grafana had that capability. If it has, let me know. I will use it. But yeah, I don't think there is, so you can do that. But that's probably the way to go. So we work a lot with the Grafana people in our integration with Influx. So maybe the next step would be to have a trace there. So.
Okay. Any questions left? Okay, then Gianluca, thank you.
Thank you.